Hi, this is Sung, and I'm the director of Sky Academy. And in this episode, up until now, we've been doing plane geometry, yes? And in this episode, what I want to do is look at a theorem that you're probably all very familiar with. It's Pythagoras Theorem. Now, you will have probably touched on Pythagoras Theorem very early on in your high school career or in your high school days. And Pythagoras Theorem has basically got to do with right angle triangles, named after the Greek mathematician Pythagoras himself. And basically it states, and it's better off that you memorize Pythagoras Theorem if you can as a word sentence describing the concept, but it's just as valid to remember the formula as well. Okay? Now, Pythagoras Theorem states that in a right triangle, in other words, a triangle with a right angle, a triangle with a right angle in it, so that in a right triangle, the sum of the squares of the two shorter sides equals the square of the longest side, which is called the hypotenuse. Okay, so the sum of the squares of the two shorter sides equals the square of the hypotenuse. All right, diagrammatically speaking, what's going on here is that in a right triangle, all right, you've got two shorter sides. Let's say those two shorter sides are A and B, right? The square, or the squares of those two sides, so in other words, if you were to draw a square with side length A and a square with side length B, then the areas of those two squares combined will be the area of the hypotenuse, or the square that the hypotenuse makes, right? So you've got, this is your hypotenuse, and you locate the hypotenuse. Number one, it's either the longest side, or number two, it's the side that's opposite the right angle, okay? And the side that's opposite the right angle will always be the longest side anyway, all right? So you've got that squared, which is c squared, which is equal to the sum of the two squares of the two shorter sides. So c squared equals to a squared plus b squared. Now, the reason I want you to remember it as the word sentence is that sometimes these letters here, what you need to remember is these letters just represent what's going on. You can use different letters, and sometimes you might see different letters. And if you were to see, for example, a squared equals to b squared plus c squared, which is probably the way some of you have been taught it, you might get confused, right? But if you just remember, oh yes, that the one on its own, the letter on its own squared, on its own, on that side of the equal sign, that's got to be the hypotenuse, because that's got to be, that squared has got to be the sum of the square of the two other sides, which are on the other side of the equal sign, not on their own, okay? So whatever letter you use for this, this, and this, right? The two that are together are the two shorter sides. The one that's sitting on its own on its side of the equal sign is the hypotenuse, okay? Now, I just basically went through that. It probably goes without saying for a lot of you, but I just went through that because for others of you, you might get confused if you see different letters, but that's really what's going on, and that is Pythagoras Theorem, okay? Now, when it comes to Pythagoras Theorem, there are basically three things you need to be able to do with it, right? The first thing that you need to be able to do is to be able to find the hypotenuse if you are given the two shorter sides. The next thing you should be able to do is to find the shorter side if you're given the hypotenuse and another side. The third thing you should be able to do is to work out whether or not a triangle is a right triangle, or if it's not a right triangle, based on the three sides that you're given, to see whether or not Pythagoras Theorem applies to it. Okay, so you've got to apply Pythagoras Theorem. If it ends up being true, or if Pythagoras Theorem ends up working, then you know it's a right triangle. If not, then it's not a right triangle. Does that make sense? So we're going to go through each of those three examples. I'm going to do the first two first. But the other thing I wanted to mention before I launch into those examples is see how Pythagoras theorem fits into the realm of plane geometry, right? Well, the other thing I wanted to say with that is that Pythagoras theorem also has application in other areas. Number one, trigonometry, right? You're dealing with triangles, so definitely in trigonometry, you will see Pythagoras theorem cropping up in all sorts of different places, right? I guess one clear example of that is when we start doing the unit circle, right? You will see Pythagoras theorem apply there. It also applies in functions and relations, and you will realize that the function of a circle, functions and relations and locus, and you'll realize that the area, the equation of a circle is essentially given by Pythagoras' theorem. Okay, and I won't spoil the surprises there, but I just want you to see that Pythagoras theorem has application in other areas. Not only that, but other areas will have application to Pythagoras' theorem. In particular, right, not necessarily in these two examples, but in particular, examples that involve surd, all right? So basic arithmetic will apply. Areas that involve, and when there's surds, you might often find that you need to do approximations, and not only approximations, but you'll also need to do rounding off to certain number of decimal places, or being able to round things off to a certain number of significant figures. And so what you'll find is that other areas, especially basic arithmetic, apply to Pythagoras theorem as well. Okay, enough said, let's launch straight into these two examples. Right, here we've got a right triangle, 5, 12, and x, and you've got to work out the hypotenuse. Now we know that the unknown is the hypotenuse, right? So we can launch straight into it and go c squared equals to a squared plus b squared. Now what we do know, and that squared looks ugly, so let's do it again. We do know that c is equal to your unknown, which is x, which is what we've got to find. Your a is equal to 5 and b is equal to 12. Now it could be the other way around, right? It really doesn't matter. You can make a 12 and b 5. It really doesn't matter because you're squaring the two shorter sides. It doesn't matter what order that you add, squaring them and then adding them, because, you know, whether you add a to b or b to a, you're going to end up with, you know, the same thing, right? So we work that out. So x squared equals to 5 squared plus 12 squared. X squared equals to 25 plus 144. X squared equals to 169. Is that right? Yes, it is. X is equal to, now the answer is going to be 13. Now the reason why it's 13, because can you think of another answer that it could be? Yeah, the other answer it could be is negative 13. The answer is going to be 13, not negative 13. The reason why it's going to be 13 is because you can't have a negative distance, and obviously x is a distance. Okay, so answer is going to be 13. Finding the shorter side then, you're going to have to be able to use equations for this. All right, so let's have a go. So now we've got c squared equals to a squared plus b squared. Now your c is going to be equal to your hypotenuse. C is always your hypotenuse if you're going to use this formula. All right, so that's going to be your 25. A is going to be R and B is going to be 24. Now, remember what I said before? A could be a 24 and R could be your B, right? You just need to remember that A and B represent the two shorter sides. And here we've got to work out what R is equal to. So in this situation, what we have is we've got 25 squared is equal to R squared plus 24 squared. Now R squared is going to be equal to 25 squared minus 24 squared, okay? So basically what we did was we brought that over to that side, right? And then we swap these around, okay? Good. So what do we have? R squared is equal to 225 minus 196, I think it is. Not 196. 176, I think it is. Yep, 176. Okay, cool. Now R will be equal to, minus that, 49. Oh, R squared is equal to 49. R is equal to 7. Got it? Now, again, R could be -7, but it won't be. The reason why it won't be is because R is a distance or a length, okay? And a distance or a length can't be negative, okay? So you need to be able to use equations or your understanding of equations to be able to work out the length of a hypotenuse and the length of the shortest side in a right triangle. The last example that we're going to be doing after I rub off this side of the board is to be able to use or to be able to prove that a triangle is or isn't a right angle triangle. Okay, so I'll be back. I'll just rub this off the board. Okay. Okay, welcome back. So now basically what I want to do is look at whether or not, or look at being able to show whether or not a triangle is either a right angle triangle or not. Okay, and in this particular example, you've got two triangles. We don't know this is a right angle triangle, so I won't make it a right angle triangle just yet. But what we've got is two triangles, right? And we're using Pythagoras' theorem to show that these are or aren't a right angle triangle. Okay, so let's do the first one. Okay, so we know that the longest side is 10, all right? Using Pythagoras' theorem, c squared equals to a squared plus b squared. We know that c squared represents the longest side, the hypotenuse, right? So left-hand side equals to 10 squared, yep, which is equal to 100. Right-hand side equals to 6 squared plus 8 squared, which is 36. 6 squared is 36, 8 squared is 64. Now, we can actually see that this one is a right angle triangle, right? Because we know one of the famous right angle triangles is a 3, 4, 5 triangle. And basically, if we double 3, 4, 5, we've got another similar triangle, right? To the 3, 4, 5 triangle. 6, 8, 10 is double the 3, 4, 5 triangle. It's similar, therefore it'll also be a right angle. The right angle will still be preserved when you enlarge or reduce a triangle. So we would expect it to be a right angle triangle. We would expect it to fit the algebra, and it certainly does, because 36 plus 64 equals to 100. So left-hand side equals to right-hand side, right? Therefore, it is a right triangle. Got it? All right, let's do the next one. I'll just rule off the board. So let's do the next one. Here we've got an 8, 9, 12 triangle. All right, so we're using the same theorem, using Pythag, c squared equals to a squared plus b squared. Now, c squared represents the longest side, so your left-hand side is going to be equal to 12 squared, which we know is 144. The right-hand side is going to be equal to a squared plus b squared, which is 8 squared plus 9 squared. So you've got 8 squared here plus 9 squared there, which is 64. 8 squared is 64. 9 squared is 81. 64 plus 81 is 145. Almost. It's very close to being a right angle triangle, but it's not exactly. You're one off, okay? And if you use trigonometry, you'll probably find that it was like 89 point whatever degrees. But it's not equal to the right-hand side. Yep, so it's not equal to the right-hand side. Therefore, it is not a right triangle. Got it? And if it's not a right triangle, you know, if it's close but no cigar, right, then it's close but no cigar, right? So you got no cigar here. All right, good. So that's Pythagoras' theorem. Now, if you want to know why Pythagoras is true, then you know, there are certainly plenty of proofs out there on the internet. If you can come up with a really ingenious, really nice, beautiful, elegant proof of Pythagoras' theorem, please let me know about it. I'd love to see it. I'd love to collect all the different ways that you can prove Pythagoras. There's more than one. But thank you very much for watching. I'll see you on the next episode. Thanks. Bye.